And I'll call you. Maybe we'll just see before it. Just one on one. No one. All right. Take care. Yeah. Yes, okay, let's start now. Sorry for the delay. I was having like network issues. Hello and welcome. We looked at organic chemistry, carbon in inorganic chemistry, octane number, and variety of organic compounds and their characteristic features and homologous series. Okay, so we stopped at homologous series, and today we're going to be looking at common characteristics of homologous series, acyl group, functional groups, and saturated and unsaturated compounds. Okay. So let's start with the common characteristics of homologous groups. Okay, so each homologous series, they have some common characteristics, and amongst them are the general method of preparation. All members are usually prepared using general methods, the same general methods. Example, the alkanes using hot soda lime on sodium base of an acid. Okay, number two is that their chemical properties, members show similar chemical properties. The alkanes are fairly unreactive under ordinary conditions. They burn in air, forming carbon dioxide, water, and they also undergo substitution reaction with other substances such as halogens. Then physical properties, the boiling point increase down the series. For each homologous series, for the physical properties like their boiling point, increases down the series. That means the bigger they get, the higher their boiling point. So that the first four elements of alkanes are gases. So first four members of the alkanes like the methane, ethane, propane, and butane, all of them are gases. And members 5 to 17 are volatile liquid, whereas the higher ones are wax-like solid at room temperatures and standard pressure. And similarly, their melting points and densities of alkanes increases, while their solubility decreases down the series. Then the difference between successive group is normally the CH2 group, as we earlier mentioned, the Akyl group. Also, there is an increase of 14 in molecular mass as the series increases. Okay, and the general molecular formula, all members share the same molecular formula, like we've already stated. So I'm going to play this video so that we can see the exact formula. Okay. Okay, so the difference is actually in the Akyl group for successive members of homologous series. So you have the first one increasing by CH2, take note. So this is how they increase, and all of them have the same general molecular formula. For the alkanes, you have the formula for the alkanes, for the alkenes, and the rest of them. So if I play this, you will get to see the formulas clearly. Okay, so this is the formula for the alkynes, CnH2n-2, whereas the formula for the alkenes are CnH2n. So those are the formulas, and that of the alkenes. So this is the formula for the alkanes, CnH2n+2. So you have to take note, these are three major homologous groups. They are noteworthy and you are supposed to know them. The alkanes, which is CnH2n+2, the alkanes, which is CnH2n, and the alkyne, which is CnH2n-2. So you need to know this, their general molecular formula. So this is the molecular formula for all the alkanes. So let's say you're talking about methane. Met is 1. So in place of N, you put 1. And you can get the formula. If you're talking about ethane, it is 2. In place of N, you put 2. So that you will be having C2H, 2 times 2 is 4 plus 6. So you're having C2H6, that's ethane. If you're talking about propane, you put 3. Solve out. You're talking about butane, you put 4. So in this last same way, you also put this for the various other groups. So take note, this is pronounced as alkanes. This is alkenes. This is alkynes. So take note. And the difference between successive homologous series is just by addition of the CH2. So let's say you have a methane. If you're going to be having ethane, so difference between methane and ethane is just the addition of CH2. So that's what we mean by successive homologous series. Now, also there is increase of 14 in molecular mass. So say the molecular mass of say methane is 1. That means the molecular mass of ethane is going to be 1 plus 14, which is 15. And the molecular mass of propane, which is the successive one, is going to be 15 plus another 14. So it's just addition of 14 in their molecular mass. That is how they progress. So I've talked about the physical property that for boiling point it increases down the series, making the first four members to be gases, the number 5 to 17 volatile liquids, and higher ones to be waxy, like solids at room temperature. Also, their chemical properties are similar. So the alkanes are fairly unreactive under ordinary conditions. Okay. So let's move forward. So what we have here is actually what we have here. But like I said, you might be confused with some of these formulas, and it's always written better on the note, the one I did myself. So take note of that. Okay. So let's move down. So looked at common characteristics of homologous series. So let's look at the Akyl group. Let's look at the Akyl group, then we'll look at the functional groups. Okay, these are groups that are derived from the alkanes by loss of hydrogen atom, known as substitution reaction. They form compounds composed of the Akyl group and the subsequent groups. The example is chloromethane. So when you have your normal methane, but one of the hydrogen of that methane is replaced by chlorine, we call it chloromethane. You know that methane is supposed to be CH4. This is supposed to be CH4, but here we're now having CH3. But so why, where there's one extra hydrogen, where has it gone to? So it's been replaced through what we call substitution reaction by chlorine. And that's why we're having CH3Cl. So you say that this CH3 is what we call methyl group, and that's why we call it Akyl. So it's supposed to be methane, but it's methyl. And that's why we call these chloromethane. So it's obtained from these by loss of one hydrogen atom, replaced with chlorine atom, just like I've explained. Then we have the Akyl groups. They have the general formula of this. So this is their general formula for the Akyl groups. So instead of having CnH2n plus 2, which is normal for alkanes, we are now having CnH2n plus 1. So it's loss of one hydrogen because the substituent group is replacing that hydrogen. Now we have Akyl groups, they have this formula and they are named after the parent alkanes by replacing the ending in with -il. They are also given represented by the symbol R. So this is a much better representation.
Today we're going to be looking at Akyl groups.
So you can see, let me put this on here so that will be explained. So you can see methane is now methyl because you now have the one of the hydrogen here. Instead of CH4, you are now having CH3. So that's the essence of this Akyl group. So it's majorly gotten during what we call substitution reaction. Okay. So let's move forward. So let's look at the functional groups. I think we're going to be stopping at functional groups today. Subsequent classes will move forward. Okay, so let's look at the fractally group of atoms. So any atom or radical or a bond common to a homologous series and which determines the main chemical property of the series is known as functional group. So the functional group is actually the atoms or the bonds or the radicals that determine the main property of the homologous series. So the Akyl group is fairly inert, as chemically because of the stability of the carbon-hydrogen bond. So any other thing that is added to that Akyl group becomes the functional group. So let's take an instance now. You have the alkanes, They don't have any functional group. The Akyl, the R, which is representing the Akyl, which is representing the Akyl, is actually the functional group. The haloalkanes, the halogens that are attached to the alkanes are actually the functional group. The alkanols, the OH that are attached to the alkyl group are the functional group. The ethers, the O and R attached to the alkyl group is the functional group. So the alkanols, the CHO is the functional group. The alkanols, it is CO, whereas the carboxylic acid, the functional group is COOH. So you need to take note of these functional groups. They are very, very important because they actually determine the chemical properties of the various homologous series that they form part of. Okay, so I'm going to give us an assignment. Number one is that we are supposed to explain to me what functional groups are with examples, what alkyl groups are with examples, and common characteristics of homologous series. Okay, so let's do that. This class is pretty short because of the network issues, but I believe we've gained a lot. And in subsequent classes, we're gonna look at saturated and unsaturated compounds, formulas, IUPAC, and isomerism. Okay, so that we'll know that it's remaining the aliphatic and aromatic compounds that are remaining. Okay, we'll still have a whole lot in organic chemistry. But have you been able to go through these videos on our website?
Yes, sir. I went through the one on physics last night, but it couldn't play. 2 a.m.
Okay.
It couldn't play. I was trying to.
Okay, you guys have to really go through them because we are planning the last week of this month. We want to work on past questions. And if you're able to go through all the videos, then when we start the past questions, it will be pretty easy for us to move very fast. So please go through them. Check out. Check, are you there now? If you can hear me, check, I'll just give an assignment. I explain what functional group is, what alkyl group is, and give the common characteristics of homologous series. Okay. Thank you. See you when I see you.